So good morning. Uh, this is the third part of storage management. So in first part, we have discussed about the basic of storages, that is storage types and all this thing. In second part, we have discussed about creating a partition on the physical storage using fdisk command. So we have discussed about the fdisk command, and after creating a partition, we have to format the partition and we have to mount the partition. So these are the three steps which we already discussed in the previous video. For creating a partition, we used fdisk command. So we have discussed about the fdisk utility and what options are available with this fdisk utility and how we can create the different types of partition using fdisk utility we already discussed. So we can create a Linux partition, swap partition, and the LVM partition. So as already we have discussed, that is we keep one of the partition as a Linux LVM partition for the logical volume management, which we have to see in this particular video. So we have created a LVM partition using fdisk command, and that partition will be used in logical volume management. Okay, so we have discussed all these things, that is for creating a partitions using fdisk tool. And we have created a file system using mkfs command, that is formatting a partition. So these are the different file system which are available, and we can create any of the file system on the created partition using mkfs utility. So we have a mkfs utility to create or format the partition, which we already discussed. So this is a way how we can use this mkfs utility, that is mkfs and the file system name and the partition name, to create that file system onto the partition. So we have a exe2, 3, 4, xfs and jfs file system inbuilt, which is available or which are available in the Linux operating system. We have created the swap partition, and we have seen the mounting of a partition, that is how we can use that particular partitions. So we have to follow the mounting process, and for that we have a command, that is mount, for mounting a partition to a particular directory, and umount command is used to unmount the partition uh, from a particular directory. And for the auto mounting, we use fs type file. In fs type file, we will make an entry where we can specify the UUID, that is universal unique ID, of the partition name, the mount location, and the what is a partition type, and we can save that file. So whenever we next time boot our system, automatically the partition will be mounted. So these things already we have discussed in more detail in previous video. So you can refer that previous video for getting the more details information about the disk utility, then mounting process and the file system. Now in this video we focused on to the third part of storage management, that is the important part, that is a logical volume management, that is called as the LVM. So before moving to the LVM, we can discuss why LVM is required. So as you know that in traditional disk storage, what we have a fixed partition, that is called the static storage management. Means we have physical partition or physical storages, and that particular physical storages are divided into a number of uh, partitions. Just like in PPT, you can see that we have two physical storages, and that physical storage is having a different partition. That is, first storage is having a partition 1, partition 2, and partition 3. Second storage is having a partition having a two partition, that is partition 4 and partition 5. What are the drawbacks of this traditional disk storage? This is a static kind of storage management. So these are the different problems which we uh, find. That is fixed partitions. So we have a fixed partition. So when we define partitions of specific size, then in runtime we are not able to change the partition size. Just like if the partition 1 is of size 100 GB, partition 2 is of 50 GB, and partition 3 is of 400 GB. So once you define that particular partition at the initial stage, we are not able to change the partition size according to our requirement at the runtime. Okay, so that is called the fixed partition. Expanding size of the partition, this is not possible. So once you define the partition 3 of size 400 GB, so we are not able to extend that particular partition. Okay, either we have to remove all the partitions and create a new partitions again with the different sizes, but the runtime, that is in the real time scenario, we are not able to change or expand the size of partition 3 or any partition. Okay, so that's why this is called as a static partition. Limitation of on size of file system and the file. Contiguous data requirement, so this is not a contiguous space, because if your database is onto the partition 2, and if that particular partition 2 is exhausted, the size of that particular or the space which is available onto the partition 2 is exhausted, you are not able to expand the database onto the partition 3. Okay, so because that database will require the uh, space continuous space for storing the data. We are not able to split the database onto the two partitions. That is, some part of the database will be available on partition 2 and then some part onto the partition 3. No, this is not possible for the database application. We are not able to split that particular database file onto the two different partitions. So that required continuous space. And last is time and effort required in planning ahead. So as these static partitions, we required a lot of time to manipulate, that is how much space will be allocated for the particular application or for the particular server, because we know that after 1 year or 2 years, if that particular capacity is exhausted, we are not able to easily expand the capacity of that particular partition. So what we have to do, we have to uh, give a more time and efforts for planning that particular partition, because all these are the static one. Okay, so what will be the solution for this? The solution is the logical volume management, LVM, which is a inbuilt functionality which is available in Linux operating system. No need to install it. The Linux or LVM commands are directly available on the Linux system. So what are the benefits of LVM? That is logical volume management. So logical volumes solve non-contiguous space problem. Okay, so non-contiguous means we already discussed that if you want to split the database onto the another partition, so this particular problem will be solved by this particular LVM. Logical volumes can span disk. Logical volume sizes can be dynamically increased. Okay, so logical volume sizes can be dynamically increased. So logical volume can be span on multiple disks. Means if you create a logical volume, so some of the space can be shared from one physical storage, some space can be shared from second physical storage, some space will be shared from the third physical storage. So the data or the space which is allocated to that particular logical volume can be shared from the multiple physical disk. Logical volume sizes can be dynamically increased. Okay, in the runtime we can change the size of your partition. Means if your logical volume size is of 2 GB, and if you want to expand it, so no problem, no need to delete that particular partition. At any instance you can expand the size of that particular partition to any size. Okay, logical volume can be mirrored, so you can create a copy of that particular partition very easily. Physical volumes are easily added to the system. Logical volumes can be relocated. So the space which is shared for the logical volume is through the physical volume. So you can easily add a physical volume in the runtime. Okay. Logical volumes can be relocated. So you can relocate logical volume from one machine to another machine. Volume group and logical volume statistics can be collected. And all these things are performed dynamically, because why we require the dynamic storage management? Because we are running a server for 24 by 7. All these are the real-time servers. So we are not able to shut down that server for a single minute. And we, as you know, that definitely year by year the space requirement for that particular servers will be increased. And to cope up with the problems, what we required a dynamic storage management. So in the runtime, we can add the storages, the physical storages into the existing infrastructure that can be easily accommodated in the existing infrastructure without switching off or without shutting down that particular infrastructure, and that particular things are easily available in the existing infrastructure. Okay, and all these things, all these activities are performed dynamically in the LVM concept. So we will see what is logical volume management. So this is a logical volume management on Linux. As you can see that we have physical volume, that is physical hard disk. So this complete block will show one physical volume. So in this diagram we have two physical volume. That particular physical volume can have a multiple partition. So P stands for the physical extent, and physical volume, that is called as a PV. Basically physical volume as an abbreviation PV, and PE stand for the physical extent, that is shown in the square shaped block. And we can create a logical volume that is shown in the red color, dotted red color. So your logical volume space can be shared from the multiple disk or from the single disk. So as you can see that first block shown from the first physical volume includes a 4 PE. So that space will be shared from the one physical volume. But as you can see, the second block having the 6 PEs, and out of that 6 PEs, first 2 PEs from the first physical volume, and remaining 4 PEs, that is physical extent, is from the second physical volume. So your space can be shared from the multiple physical storages because this is a logical volume. So it do not bother from where that space will be available. It will simply take the space from the multiple. Means if you are having a 10 different hard disk drive, so 1 GB can be allocated from one hard disk. Second GB can be allocated from the second hard disk drive. So if your logical volume is of 10 GB, so that 10 GB can be allocated from all the 10 hard disks, or from one hard disk or two hard disks or three hard disks. So that doesn't bother because all these are the logical. So that space can be shared from any physical volume. So this is a physical volume, this is a physical extent, which is a part of your logical volume, and these are the logical volume which we can create, and this is a volume group. So blue line will show you a volume group, complete volume group. So one volume group can have a multiple physical volume, and that particular physical volume can have a multiple logical volume. So volume group is nothing but a cluster which we create for the physical volume. Okay, so volume group will consolidate all this physical volume in a one name. So when we create a logical volume, that will not directly create within this particular physical volume, that is through the volume group. So as we can see the commands for that, so this particular concept will be clear. So here you can just remember the terminology, that is physical volume. Physical volume are nothing but standalone physical storage devices. P are the part of that particular physical volume, that is physical extent, and logical volume can be created over this particular physical volume. And volume group is nothing but a logical group which we create for all this physical volume. Okay, So what is logical volume management? Logical volume management solves the disadvantage of traditional disk storage. One or more physical volume, then hard disk partitions are assigned to the volume group. As you can see that physical volume. Okay, one or more physical volumes are assigned to a volume group. So as you can see, this particular blue line is a volume group and two physical volumes. This particular uh, cylindrical shape will show the one physical volume and this is the second physical volume. So two physical volume is a part of your volume group. Okay, so here two volumes are shown, but we can have a multiple. Okay, all physical volumes are split into the physical extent. Okay, so all physical volumes are split into a physical extent that is called the PE of identical size. Default is 4 MB. So whatever space are available within this physical volume are divided into equal parts that is called the physical extent, and the default size for that particular physical extent is 4 MB. Okay, so every PE here is of 4 MB. P's in the VG can be combined into a logical volume. So physical extent in a volume group can be combined into a logical volume, which can be used like any block devices. So when we create a logical volume, the logical volume is consist of PEs. Okay, so how this logical volume is created? This consists of P. So if you consider this is one of the physical volume, logical volume which is created of 6P. So what is the size of this particular logical volume? 6 into 6. 6 into 6. 6 into 4. So 6 P's are there and 4 MB is the size of 1 P. So 24 MB. So what is the size of this particular logical volume? That is 24 MB is the size. If you consider this particular block, then 4 P's are there in one logical volume and 1 P is of 4 MB size. So 4 for the 16. So 16 MB is the size of this particular logical volume. Okay, so this logical volume can be created using a PEs, and LV can be span multiple disks. So logical volume can span multiple disks. You can see that. So logical volume, the P's can be shared from this particular physical volume. Some P's can be shared from this physical volume. So this is called a spanning of this particular logical volume onto the multiple groups. To increase the size of LV, add PEs. Okay, if you want to increase size of logical volume, what you have to do? You have to add more P's, physical extent. To increase the size of volume group, we have to add more PBs. Means if you want to increase the capacity of this volume group, what you have to do? We have to add more number of physical volume. Okay, this concept is very important. Means if you want to increase the capacity of volume group, if you consider this particular first physical volume is of 100 GB and second physical volume is of 100 GB. So what will be the total capacity of this volume group? That is a 200 GB. Now, if you want a more hard disk space, that is 200 GB is now exhausted, and you want more 200 GB more space. So what you do? You can add one more physical volume into this volume group. You can add one more physical volume into a volume group. So this is the first step of logical volume management. Okay. If you want to increase the capacity of this logical volume, so definitely what you have to do first, we have to create the physical volume. Physical volume will be added into the volume group, so it will increase the capacity of your volume group. And now you can add more P's into the logical volume. So the capacity of this logical volume will be increased. So all these are correlated with each other. So if you want to increase the capacity of logical volume, you have to add a more P's into that. Okay, means if the capacity of this particular lower logical partition is that is 6 for the 24, and if you want to make this particular as a 32 MB, okay, so what you have to do? You require two more P's. So already this P is used, and only the one P is left here, that is PE1. So what you do, you have to add more physical volume. So one P is not sufficient because you want to extend this particular logical volume to 32 MB. And how many is available now? The size of this particular logical volume is 24 MB. So adding only a single P is not sufficient for making it to the 32 MB. So what you do? You have to add one more physical volume into that. Okay. So we have to add the physical volume into the volume group. So more number of P's will be added here. And when the more number of P's will be available, you can extend the capacity of logical volume. And this is called as a logical volume management. Means adding the PV, creating the volume group, adding the physical volume into a volume group. Okay. Then creating the logical volume, extending the capacity of the logical volume, reducing the capacity of the logical volume, all part of the logical volume management, that is LVM. So we will see what are the commands are available for that. So LVM has three layers. Basically, all these are correlated. So at the bottom layer, we have the physical volumes. In the middle layer, we have a volume group. And at the top level, we have a logical volume. So this logical volume will be created from the volume group, and volume group will be created using a physical volumes. Okay, so all these are correlated with each other. So how we can go for the LVM, that is logical volume management. So Linux will offer you a different commands for logical volume management, and basically all these commands are divided into three different parts. That is, first set of commands are related with the physical volume, which is used to create a physical volume, which is used to remove a physical volume, and which is used to display a physical volumes which are available on your system. Okay. Second set of commands is called as a volume group. So once you create a physical volume, then second step is that we have to add that particular physical volumes into a volume group, into a volume group. So either you can create your own volume group, or you can add a physical volume into an existing volume group. So for that we have a VG create command for creating a volume group. Okay. If you want to remove that particular created volume group, then we have a VG remove command, VG extend. So if you want to increase the capacity of that particular volume group, just like we had discussed earlier, that is, we have this diagram. So these two physical volumes are not sufficient now. We have to add one more physical volume. So first, what you have to do first? We have to create a physical volume first using PV create command. Then by using VG extend command, we can add that particular physical volume into a volume group. So that is the second activity which we have to perform. So for that we have a command, that is VG extend. VG reduce means if you want to remove any physical volume from that particular volume group, then we have a command, that is VG reduce. And last command is VG display or VGS. VGS will list all the volume grids which are available onto the system, and VG display is again similar to the VGS. It will again list all the volume groups which are available, but with the more detailed information. Okay. So once you create this volume group, what is the next step? The next step is creating a logical volume, that is logical partition. So first step we have created the physical volume. In second step we have created a volume group and added that particular physical volume into a volume group. Now the third step is that we can create a logical volume. Okay. So how we can create? Again, a set of commands are available, that is LV create. LV create stands for the logical volume create. LV remove means if you want to delete any logical volume partition, then we can use the LV remove command and we can specify the partition name. Then we have a LV extend command for extending or increasing the capacity of that particular logical volume. So if your logical volume which we have created is of 2 GB, and now we require more space into that particular logical volume. So how we can do that? By using lv extend command, we can increase the capacity of that particular existed uh, logical volume. So no need to delete or whatever. Simply whatever partitions you have, you can use that particular partition, and by using lv extend command, we can increase the capacity of that particular logical partition. lv reduce, sometimes if you have created a logical partitions of higher capacity, just like of 10 GB, and in future you feel that this 10 GB is not required for that particular application or the server, the 3 GB or 4 GB is sufficient for that particular application, because 6 GB is unnecessary investing. So what you do, you can reduce the capacity of that partition in the runtime. So already the size of that particular partition is 10 GB, and if you want to reduce it to 4 GB, then lv reduce command is used. And last command is that is lvs for displaying all the logical volumes. So lv display will provide more detailed information. lvs simply list a particular partition in a tabular format with some basic information. So in logical volume management, these are the three steps which are more important, and you have to follow that particular sequence. That is, first is creating the physical volume, second is creating a volume group and adding a physical volume into a volume group, and third one is a logical volume commands for creating the logical volume, removing the logical partition, then extending the logical partition, or reducing the logical partition, or displaying whatever logical partitions you have. So we will go for first step, that is creating a physical volume. We can see all these commands in more details. So what options are required, what are the arguments are required with that command. So first command is a pv create. Okay, so this particular create is a very simple command. So you can write down the pv create. So all these commands will be executed from the root user or the super user. Okay, and what are the argument which is required with pv create command? The argument is the device name or the storage name which we have specified in the fdis command. तो fdis में आपने जो partition lvm के लिए रखा है, okay, that partition name will be specified here with the absolute address. Just like if you consider in the hard disk B, we have created the SDB6 as a Linux LVM partition. Okay, so what you do, you can first convert that particular partition into a physical volume. So this first command will convert that particular SDB6 into a physical volume. So that is important. Without creating a physical volume, we are not able to add that particular physical volume into a volume group. So you have to do this particular activity at the initial. So pv create slash dev slash sdb6. So whenever we create a partition, that will be goes into a dv directory. So absolute path will be required here. So slash dev slash sdb6, or you can specify the multiple partition at a time for creating the physical volume. So here partition 6, partition 7, partition 8 are converted into a physical volume by using a single command. Then to verify whether that particular partitions are created or not, you can go for the pvs command to display all the physical volume created. Use this pvs, and then to get the detailed information about each pv with uh, if you want to know the detailed information of a particular physical volume, then you can use this command, that is pv display slash dv slash sdb6. So it will show a more detailed information about this particular sdb6. Okay, so this is the first step, which is used to create a physical volume, and the command is pv create. Okay, now second command is that is creating a volume group. So for that we have a command vg create. So before that you can list all the volume groups which are available onto the system using vgs command. So without any argument, when we execute this vgs, it will list all the volume groups which are available on your Linux machine. Okay, once you verify what volume groups are available, you can create your own volume group using a next command, that is vg create. So in this we required two arguments with the vg create command. So vg create is the new volume group. So you can specify your own name, or uh, you can specify your own volume group name. So here I am given my underscore volume grp is a volume group name for my volume group. And what partition I want to add? So whenever we create a new volume group, we have to add one physical volume into that. Okay, so you remember that first of all you create this particular physical volume. So in first step before this, we have converted this particular SDB6 into a physical volume, and now we are adding this particular physical volume into the newly created volume group. So this particular command will create this volume group, my underscore vol grp, and this particular SDB6, that is physical volume, are added into the volume group. Okay, because suppose if you have already a volume group is created, I want to add one more physical volume into that volume group. So I have a command that is bg extend. So I added one SDB6 into that particular volume group earlier. Okay, now I want to increase the capacity of this volume group, and that is called as extending the capacity. So what is the command? That is vg extend my underscore volume group, that is volume group name, which is already available, that you have to specify, and you have to specify a physical volume name. We call it as a PV now, because we have converted this particular SDB7 into the PV. So this PV is added into this particular existed volume group. So it will increase the capacity of this volume group. Okay. If you want to reduce the capacity of this volume group, then we have a command that is vg reduce. You have to specify uh, what is a volume group name, and which partition you want to remove it from that particular volume group, that you have to specify. So I want to delete this particular physical volume from this particular volume group. So I have added that, and by using vg reduce, I have removed this particular partition, that is SDB7, from this volume group. Okay, so this is a VGS command which is used to display all the volume groups. VG create, which is used to create a volume group. So what are the arguments which is required? That is group name, that is a new group name, and the PV which you want to add into that volume group. For extending and reducing, we have a VG extend command and VG reduce command. And finally, once we create a volume group, in that volume group we can create a logical volume. So where the logical volume will be created, not from the physical volume, that will be created from the logical volume. So for that we have this command, that is lv create, lv remove, lv extend, lv reduce, and lv display or lvs. So one by one we can see that command. So how we can create a new logical volume group, logical volume, not a group, that is logical volume, that is lv. So command is lv create, and argument is minus n. Minus n stand for the name of that particular logical volume. So new volume name. So minus n space, and you have to specify a volume name minus capital L size. So of what size you want to create a particular partition, that size you can specify. Either you want to create a logical volume of 2 GB, 3 GB, 10 GB. So you have to specify minus L space and 10G, 2G, or 5G. And Last argument is that is a volume group name. So this is not a physical volume name. What you have to specify? You have to specify the volume group name here. So we have created the volume group, that is my volume group. So this I have to specify by creating the लॉजिकल वॉल्यूम. दिस इज इम्पोर्टेंट वन. कहाँ से हम लोग बना रहे हैं? हम लोग वॉल्यूम ग्रुप से बना रहे हैं. फिजिकल वॉल्यूम इज अ पार्ट ऑफ दैट वॉल्यूम ग्रुप, बट फ्रॉम वेयर आई एम क्रिएटिंग दैट माय लॉजिकल वॉल्यूम फ्रॉम द volume group name. These are the examples how we can create this particular logical volume. These are the different ways. So LV create. So here I am creating my first logical volume, that is uh, my minus n my underscore lvm1. So this is the name of that particular logical volume I am giving. Minus l 10g. So 10g is the 10 GB is the capacity of that particular logical volume I want to create, and from where I want to create this particular partition, that is my volume group. Okay, this is a one way. LV create. This is another way, that is minus n, then volume name माइनस स्मॉल एस 100% फ्री. तो जितनी भी फ्री स्पेस, जैसे आपका अगर वॉल्यूम ग्रुप में अगर 20 GB है एंड ऑलरेडी उसमें से दो 5-5 GB के पार्टीशन बने, नाउ हाउ मच मेमोरी स्पेस इज लेफ्ट इनटू दैट पर्टिकुलर वॉल्यूम ग्रुप? दैट इज 10 GB. But I don't know how much memory space is available into that particular volume group. So what I will do, see whatever remains space are there, it will take 100% of that. So that's why here written that is minus L 100% of free. तो जितनी भी free space रहेगी, either that will be 8 GB, 10 GB, 15 GB. Okay, it will take that particular GB. तो यहाँ पे मैं क्या बोल रहा हूँ, जितने भी बची space है my volume group में वो सारी consume करना है for creating this particular partition. Or either you can use this command minus minus name, then volume group name, sorry, logical volume name, minus minus size, capacity in terms of GB, that is 2G, and the volume group name. So these are the different ways of creating the logical volume using LV create command. Okay, LV extend. If you want to extend or reduce the capacity of the logical volume, then we have LV extend command. So first we will see how we can extend the logical volume. So first command is LV extend minus L 100, and you have to specify. So whenever we create the volume, logical volume, what is the location of that? This is important again. You can remember that is it will create a DEV slash my volume group. So under DEV, first it will create the my volume group. So this is the name of volume group which I have created, and within that particular my volume group, I have created my LV1, my logical volume one. Okay, so I want to extend that particular. If you consider already this my LV1 is of 80 MB, and I have specified that is LV extend minus L100. So what it does, it will make the size of that particular my LV into 100. It will not add the 100 MB, but it will make that particular partition of 100 MB. तो अगर 80 MB है तो क्या करेगा, उसमें 20 MB और ऐड करेगा एंड इट कम्स टू द 100 MB. अगर आप इस तरह से स्पेसिफाई करते हो प्लस 100, okay, so plus 100 means whatever the existing capacity which are available into the my LV1. Suppose this my LV1 is of 80 MB, and if you are specifying minus L plus 100, so now what will be the size of that my LV1? That size of that particular my LV1 is now 180 MB. So already 80 MB capacity or size is available. You are adding plus 100 MB to that. The total size of that particular my LV1 is now 180 MB. Okay. This is another way, that is minus minus size plus 2G. So 2 GB will be added just like plus 100 MB. Then next is reducing the size of that particular logical volume. So how we can reduce? That is minus minus size 2 GB. So then 2 GB will be reduced, or either you can specify minus L minus 2.5 GB. So it will reduce. 2.5 GB from that particular LVM. Okay, so this is about logical volume management. So simple commands are there. So first command we have to create the physical volume using PV create. In second step we have to create a volume group and add that particular physical volume into a volume group, and then you can create the logical volume out of that particular volume group. And we have some additional command, that is LV extend, LV reduce, LV remove to remove the partition, or LVS to display all this logical volume partitions. So LVS is one of the command, LV display is again a command, and LV remove. So LV remove means LV remove, and you can specify this complete address to remove that particular logical partition. So LV remove slash DUV slash my volume group slash my LVM1, that you have to specify to remove that particular logical volume. Okay, and once you create the partition, you have to follow the same steps which we have followed after the fdis command, that is formatting the partition. So same, because these are partition, तो fdis से हमने डायरेक्ट पार्टीशन बनाया था, उसके बाद उसको फॉर्मेट किया था और माउंटिंग किया था. So same process we have to follow after creating this particular logical volume, because logical volume is again a partition. So this is a raw partition. Then after we have to use this mkfs command to create a file system onto that particular partition. तो ये command हमने already देखी है अब इसके बाद. So you have to use the same command mkfs dot file system name if you want to create ext4, and you have to specify the absolute path of that particular logical volume. So what is the absolute path here? That is slash dv slash my underscore volume group my lv1. Okay, so you have to create a file system over that. Then you have to follow the mounting process, because when we create this my lv1, again this is not directly accessible to you. So you have to follow the same mounting process which we explained or studied after fdis command. So you have to use a mount command. Mount, you have to create a mount point, and you have to specify this particular mount partition and the mount point to mount the partition. Then this particular my LVM is available for use. Okay, so this is all about the logical volume management and the command which are related with the logical volume management. And these are some of the commands which is or utility commands which are available for checking the file system and for the auto recovery. For your knowledge, you can just uh, go through it. So for checking this particular file system for the consistency, that is the ext2, ext3, ext4, we have e2fsck utility to check this file system. Okay, just like in Windows operating system, we have a chkdsk command which is used to check the consistency of your partition. So similarly, we have utility tools for checking the partition. So for ext2, ext3, ext4, we have e2fsck tool. For xfs file system, we have xfs underscore repair, and for the jfs file system, we have a jfs underscore fsck. Okay, so these are the simple utilities which are available for checking the consistency of file system which we have created onto the partition. Okay, so these are all about the storage management. So in storage management, we have seen the basic of storage, we have seen the disk utility, we have seen file system and the creation of file system using a mkfs command. We have seen mounting process, we have seen how we can create the swap partition, okay, using mkswap command. Okay, and finally for the dynamic storage management, we had discussed about a logical volume management. So this is a replacement of static storage management, and for that we have a different set of commands, that is for the physical volume, for volume group, and the logical volume. So this is all about storage management. So in next video, we can see execution of all the commands, that is fdisk for creation of a partition, and how we can create a file system onto the partition, how we can do a mounting of a partition into a mount location, and then we can see the execution of logical volume management commands on the Redhat system.